Let's try and understand SHM with a pendulum. Alright. Now a pendulum is moving this way. Alright. A simple harmonic motion, mean position, extreme position. Now keep one thing in mind, whenever it goes from here to here, we say that it has moved by pi by 2. Alright. So it goes from here to mean position to extreme position, it has moved pi by 2. Again, when it comes back from extreme position to mean position, that means it has traversed another pi by 2. So pi by 2 plus pi by 2, pi. Alright, so when it is coming back to mean position from positive extreme, and then it would be moving towards negative extreme, so another pi by 2. So now when it is over here, so it has gone here, it has come back here, and then gone here. So it becomes pi by 2 plus pi by 2, so 3 pi by 2. And then when it returns back to mean position again, another pi by 2 covered. So it is pi by 2 plus pi by 2 plus pi by 2 plus pi by 2, which becomes 2 pi. And that is what is one oscillation. Alright, we would see the graphical aspect of it. So this is what you have got to keep in mind whenever we are talking in terms of SHM. So pendulum, bob, string, bob, pendulum. Alright, okay. So we already have derived formula for displacement, x is equal to a sine omega t. That was the formula for displacement. Then if we want to get velocity, what do? We d by dt of x. That's what is velocity. So when we do a d by dt of sine omega t, so chain rule we have got to apply. So d by dt of omega t also have got to be done. So when we do this, dt gets cancelled. So omega remains over here. So that omega comes out here. So a omega, a was out because we know constant is always taken out of differentiation, d by dt. Alright. So this omega comes here, a omega, and sine gets converted to cos. So a omega cos omega t is for velocity. Acceleration, and if we want to get acceleration out of it, then we do dv by dt. So again a omega and differentiate d by dt of cos omega t and chain rule. So we do omega. Now here I just for clarity I wrote omega, which is taken out, a chain rule for this, chain rule for this. So omega, which is a constant, is out of d by dt, and the t which was there, that is dt by dt, which gets cancelled. So omega remains, that omega comes here and it forms and cos, we know whenever we are differentiating any c items, c trigo functions, whenever we are differentiating any c function, whether it be cos, whether it be cosec, whether it be or cot, sign changes. So here it is c, that is cos, so it becomes minus a omega square sine omega t. So we got three equations now for displacement, velocity and acceleration. Have got to keep in mind. Alright, okay, now let us get further. Now let's try and understand what we have in this part of video. Let's suppose that the simple harmonic motion begins from mean position, that is, it is starting from here and going this way, and then would be coming back here and then going this way and this way, completing period, and that would keep on happening. Alright, so here it starts from mean position and moves towards positive direction. This is positive direction, this is negative direction. Alright, so as I explained earlier in my earlier video, that if it starts from here, then if it starts from mean position, the phase is 0. Alright, but if it starts from here, say from positive direction, then the phase would be pi by 2. Phi would be pi by 2. And suppose if it has moved there and come back here, and now it is going to move that side, so then the phase becomes pi by 2 plus pi by 2, that is pi. Alright, and so on and so forth. Alright, we would be dealing with that little later. Right now let's deal with when the bob starts moving from mean position towards positive direction. So phi is equal to 0. So this was our formula, x is equal to this. We substitute there 0. As a result, the formula gets converted to x is equal to a sine omega t. Alright, so x is equal to a sine omega t, which we differentiate applying chain rule over here. A d by dt of sine omega t into chain rule, omega dt by dt, omega being constant comes out and dt differentiated, so it gets cancelled. So that omega comes out over here and it forms a, which already was there, and new omega which we got from here, and sine gets converted to cos omega t. So a omega v is equal to a omega cos omega t. Alright, now it's a omega cos omega t. So it's a cos curve. So that's what we see. It's a cos curve, right? Cos curve. This is a sine curve, and we know the phase difference between sine and cos curve is pi by 2. This we had seen, pi by 2, right? From here to first amplitude is pi by 2. So here to here is pi by 2. And it's starting from here, that is from here. So the phase difference between the two is pi by 2. Anyways, let's progress. That we would be seeing later on. And I have also mentioned over here non-trigonometric formula for velocity, which was plus minus omega root of a square minus x square. Fine. So now we want to get acceleration. So differentiate v dv by dt. Alright, so we differentiate dv by dt. A omega being constant stays out, d by dt of cos omega t. Alright, and chain rule applied to omega t. So it is omega dt by dt gets cancelled. This omega comes out, forms a omega square, and cos now gets converted to sine. And another thing that you've got to keep in mind is whenever we are differentiating any trigonometric function starting with c, that is cos, cot or cosec, it's accompanied with negative sign. So here also we have cos, so d by dt of cos is negative, and cos gets converted to its counterpart, that is sine omega t. So this is the equation for acceleration. This again you have got to keep in mind. Alright, so this a omega square sine omega t is again sine curve but negative. It is sine curve but negative. So that's what we see. If it would have been positive sine curve, it would have gone that way. Starting from origin, yes, it starts from an origin. Sine always, sine curve, sinusoidal curve always starts from origin. Now this also is starting from origin, so it's also sinusoidal curve but towards the negative direction. That's why it's minus a omega square, so it's that way. So this is how the graph and the equation sets in. Alright, and it can be correlated with this. Alright, okay, now let's understand when the bob starts from extreme position, starts from positive extreme position from here. Alright, now it's moving from here to there. Alright, so already I mentioned that the phase difference between the two is pi by 2. This is pi by 2, this is pi by 2. Alright, so phase difference is pi by 2. So now instead of 5, we would be putting in pi by 2. Now this already I have mentioned that in allied angle, if it is pi by 2 plus theta, this we can assume it as theta. So pi by 2 plus theta, then now pi by 2, since it's odd, it is 1 pi by 2. So sine gets converted to cos. So that is what it is, and theta remains as it is theta. And the sine of this would be followed by this sine. Now we know pi by 2 plus theta comes in second quadrant, and in second quadrant sine is positive, so sine is positive. Alright, so it is a cos omega t. So if you compare that with this, now see, this is cos curve. So whenever we are starting from extreme position, we get a cos curve. Whereas whenever we are starting from mean position for displacement, we get sine curve. Alright, so okay, that's the difference in curve. Now let's see what happens in case of velocity. In case of velocity, we differentiate this again, dx by dt. So it would be a being constant out, d by dt of cos omega t, chain rule omega dt, dt goes away, so this omega comes out. So this becomes, now mind you, this is c, so minus, and this omega is here, so minus a omega sine omega t. Now velocity becomes the sine curve and negative sine curve. See, check out over here, it is negative sine curve, right? So negative sine curve. And I forgot to mention, now this y-axis is for displacement, here y-axis is for velocity, and here y-axis is for acceleration, and this is for time. All right. So in case of velocity, what we find is it is again a sine curve but negative sine curve, whereas here what we find for velocity, it is a cos curve, positive cos curve. Fine. So that's again the difference. I just made it simultaneously so that you can compare and understand trigonometric as well as graphical difference between the two when started from mean position and when started from extreme position. Fine. Let's now get into acceleration. In case of acceleration, what we do is we differentiate velocity dv by dt. So a omega minus a omega was already there. So minus a omega d by dt of sine omega t, and chain rule omega dt, dt gets cancelled, 1 omega adds and multiplies over here, so it becomes minus a omega square, and sine gets converted to cos omega t. So now see, now it formed cos curve, so it is minus a omega square, so it is cos curve but negative, whereas here we found that it was sine curve but negative. So when it started with mean position, the acceleration graph showed sine curve but negative, whereas here it is cos curve but negative. Alright, so this is the difference. Next video would be presenting still more in detail about when started from mean position and when started from extreme position, about the phase differences. Alright, okay.